What if you could flip a switch and completely change the fundamental property of a material? Not like turning on a light, but transforming how electricity flows through the metal itself. For years, this wasn't science fiction. It was a real, observed mystery in one of the most exotic materials ever discovered, Kagome Metals. Scientists saw this strange electrical switching effect in the lab, but for the longest time, they couldn't explain it. The quantum physics involved were just too complex. So, what changed? According to the researchers, a perfect storm of three critical elements finally came together. First, we had the materials. Kagome Metals, only discovered around 2020, provided the perfect ultra-clean canvas for this quantum phenomenon to appear. Second, we had the theory. Advanced new concepts in quantum physics, like understanding loop currents and quantum geometry, gave us the language to describe what was happening. And third, we had the technology. Ultra-sensitive equipment that could probe these materials without disrupting their delicate quantum states. As Professor Hiroshi Kontani, a lead scientist on the project, put it, this discovery happened because three things came together at just the right time. None of these existed together until very recently, which is why no one could solve this puzzle before now. The puzzle, for the first time, had a solution. So, what is the secret? Let's break it down. Inside a Kagome metal, electrons don't just flow in a straight line. They can form what are called loop currents. Imagine these as tiny microscopic whirlpools of electricity swirling in a specific, stable pattern. This is the default state. Now, here's the switch. When an external magnetic field is applied, it interacts with the quantum geometry of these loops, the very shape of their probability waves. This interaction is so powerful that it can force every single loop current to suddenly flip direction. This collective flip of all the loop currents is what changes the fundamental way electricity travels through the entire piece of metal. It's not just a small adjustment, it's a phase transition, a reprogramming of the material's electronic personality. This effect is incredibly delicate. That's why it remained hidden for so long. The quantum dance of loop currents is easily disrupted. Even a single impurity atom, a little physical strain on the crystal, or the wrong temperature can destroy the synchronized flip. You need an absolutely perfect Kagome metal to see it, which is why the recent discovery of these pure materials was the final, crucial key. So, why does this matter? Because this discovery gives us a powerful new tool: magnetic control over a material's deepest electrical properties. Professor Kontani believes this could lead to new types of magnetic memory devices, faster, denser, and more efficient than anything we have today. Or imagine ultra-sensitive sensors that can detect the subtlest magnetic signals, revolutionizing fields from medicine to engineering. This isn't just about making existing tech better. It's about building a new foundation for the next generation of technology, controlled by the laws of quantum physics. For decades, we've built technology with the materials we have. But this breakthrough opens a door to a future where we can program the materials themselves. The quantum switch has been found. Now, the real work of building the future begins.